I am Ang from EIT Solutions. I am host for today's talk. In today's talk, we invited experts from 8 Japan engineering consultants, EJIT, to share their advanced technologies used in inspection and maintenance of bridges in Japan. EJIT provides the professional consulting services, and they have extensive experience in the areas of environment and energy, natural disaster risk reduction, urban regeneration, infrastructure management, and information and communication sectors. First, let me introduce our speakers. Engineer Masayuki is a group sub-manager in Infrastructure Technology Group of EJIT Information Technology Center, and Engineer Rupesh is a staff member of Infrastructure Technology Group of EJIT Information Technology Center of EJIT. Let me welcome our experts. Now let me welcome our experts to present digital transformation development in bridge maintenance in Japan. If you have any questions, please send the message in the text box. Thank you.
Okay. Hello, everybody. I'm SHOUBUZAKO from Japan. I have been working at Japan engineering consultant for 27 years. Basically, in the field of I have been working in infrastructure maintenance and conservation. Originally, I wanted to give a presentation there, but I'm sorry, I could not come to Thailand this time because of COVID-19. He is Rupesh, who is developing new technology with me.
Good afternoon, everyone. I am Rupesh MACHAMASI, and it's my pleasure to be a part of this presentation. Thank you so much.
Please wait a moment. I will share my screen. Okay. Is my screen visible?
Yes, it is visible.
Okay. Today, we would like to introduce some example of our research and development on DX technology, digital transformation, and bridge maintenance in Japan. We do not make the robot party, rather provide ideas to improve operating software and function of the robots for DX technology in bridge maintenance to various specialized manufacturers. I will give you a brief overview of today's presentation. After that, Rupesh will continue the presentation on the detail of the contents. Let's start with the background. Japan achieved an average annual economic growth of more than 10%, around 20 years from 1950s. The infrastructure constructed during that period were designed with a service life of 50 years, and most of them are still in use. It is financially difficult and unrealistic to renovate all the structures constructed during that period. For this reason, Japan has entered an era of maintenance following new construction. For existing infrastructures, the road law demands regular inspections once in every 5 years. There are about 720,000 bridges in Japan. About 144,000 bridges are regularly inspected every year. And also, huge regular inspection cost is required. In addition, the shortage of manpower for regular inspection is becoming a challenge to overcome. In Japan, DX, which developed and utilizes support technology to replace humans, is being promoted in order to solve the above problems. The inspection support technology is technology using robots, AI, and ICT that can obtain the same result as a close-up visual inspection performed by humans. The technology introduced today is based on the perspective of DX, and in order to make the major shift from the conventional method, we examined the mechanism and the specific method of inspection of structures such as bridges. This new method is more efficient and safer. It also improves accuracy and allows multiple specialists to share information at the same time to make the right decision and assessment. There are the topics we talk on today, and it is divided into two parts. Firstly, research and development, and this we have number one, advanced bridge inspection and DX using drone. Number two, utilization of 3D scanning and development of 360 degrees editor. Number three, development of water drone. Number four, emergency damage reporting, development of local live stream with 4K web camera. Secondly, under introduction of non-destructive testing, we have number one, concrete tester used for testing compressive strength of concrete. Number two, ORIS exploration used for shape and damage exploration of structures. Thank you, everyone. Rupesh will continue the presentation hereafter. Mr. Rupesh, please continue the presentation.
Thank you, Mr. SHOUBUZAKO-san. In continuation on the research and development, the first topic which we have is advanced bridge inspection and DX using drone. We would like to give a brief introduction of infrastructure inspection and general bridge inspection methods that are being employed these days. Basically, infrastructure inspection involves a collection of visual information of the site condition or damages, if any, taking measurements, conducting simple non-destructive tests like surface salinity test, compressive strength test, etc. The general inspection methods that are being employed these days are as follows: the ground level inspection, inspection using ladder, inspection using bridge inspection vehicles. These are frequently used methods, whereas on the special occasion or special sites, inspection through rope accesses and boat, etc. can also be employed. However, all these conventional methods are labor intensive and quite time consuming. But in recent days, technologies such as drones, scanner, etc. are also being employed to carry out inspection and investigations work. So in this session, we would like to talk about the utilization of drone in inspection and its advantages. So while conducting inspection in roads, especially in busy roads, it is often necessary to regulate the moving traffic to ensure the smooth traffic flow And enforcing road traffic regulation may sometimes leads to unwanted traffic congestion, which may be inconvenient to the most of the road users who are in rush. Therefore, using drone, this inconvenient road regulation is not necessary to be enforced. Likewise, safety issues are of priority concern in inspection, and human casualties or risks of accidents in dangerous places, for instance, breakage of ropes in rope access, fall from the bucket of the inspection vehicle, etc., can be completely eliminated by the using drone in the inspection. Similarly, the conventional bridge inspection method requires a large number of manpower and time, which consequently increases the overall cost of the inspection. Therefore, the inspection using drone can be conducted with less manpower and in less time. Hence, the problem of manpower shortage in inspection can also be addressed using the drone. Due to the above reasons, drone inspection is preferable than other conventional inspection methods. So today we would like to introduce you to a high-performance small non-collision drone, which is Skydio J2. The general features of this drone is similar to the other drones. However, this drone has some special features, which is better than its close competitors. So let's move on to the strengths of J2. So the first features of Skydio J2 drone is vertical or upper part shooting ability. While undergoing bridge inspection with drone, the drone employed should have the ability to shoot vertically to ensure the efficient coverage or better view of the target. Generally, the shooting camera of a normal drone is mounted facing down, which is why it captures images or videos facing the ground from the sky. To facilitate the vertical shooting, technological advancement to improve the drone camera has been made. In particular, Skydio J2 has its main front camera attached with the gimbal setup so that the drone operator can adjust the shooting angle up to 180 degrees vertically. The Skydio has a unique function that allows the camera to face straight up and making it easy to shoot the ceiling under a bridge, which was difficult to shoot with a conventional small drone. Second is the collision avoidance function. General drones are difficult to use in narrow spaces between girders and trusses due to the risk of collision. However, the Skydio J2 can be operated safely even by pilots who have no experience in operating drones in such places. Skydio J2 has 6 sensor cameras mounted on the top and bottom surface of the drone that take 360-degree picture, and the image just taken is analyzed by AI to check the surroundings to recognize the object in 3D and avoid collision. Obstacle avoidance allows the drone operator to navigate through tight spaces and conduct close-up inspection of detailed assets. We can choose from 3 obstacle avoidance mode in the settings. The first one is the standard mode, which provides a safety barrier of 87 centimeter between the Skydio and obstacle. Likewise, close mode provides keeps the drone 28 centimeter apart from the obstacle. And minimum mode gives an 11 centimeter of safety barrier between the drone and the obstacle. We can also disable the obstacle avoidance feature. However, the disabled obstacle avoidance settings should only be used by the experienced pilot. Skydio J2 can also be flown on the weak or non-GPS environment. Like I already have mentioned before, Skydio J2 has 6 superficie lens sensor that take 360-degree image, which is analyzed by AI. Thus, any obstacle near the surrounding is recognized to avoid collision. With these 2 features, collision avoidance and flight under non-GPS environment, the J2 has an easy access in the narrow spaces between girders and beams. Video on the right, on the left is taken from a normal camera that shows the drone entering the narrow areas smoothly, whereas the video on the right is the recorded video feed, what the drone is looking at. To understand the features more clearly, let me play a short clip of an actual drone inspection. Since a drone is small in size, takeoff and landing can be done in hand. This drone can be flown very close to the bridge component due to ways taking photographs become smaller as close-up manual inspection. Flying under weak GPS condition such as in under the bridge, also without the risk of collision is also possible. This drone is operated by using iPad or joystick controller as many other drones. So with frequent use of drone technology in inspection, some shortcomings have been noticed. If significant, for example, in case of significant damage, it is quite difficult to check the small controller screen by many people at the same time. Moreover, in a situation like COVID-19, it is not recommended to gather closely together and have a look on the screen as shown in the picture. Also, there may be risks of interference of pilot operation if many hand touches are made on the controller. To avoid those risks, mirroring of the controller screen can be done with a large monitor, but the volume of the luggage to be carried to the site increases. With continuous study and improvement in technology, to solve the requirement of multiple drone view while undergoing inspection, the smart glass technology was combined with a high-performance video transmitter, due to which the damage evaluator, primary inspector, and the drone operator can have the same drone view at the same time without any risks of interfering the drone operation. As we can see in this picture, the damage evaluator inspector are sitting comfortably on the chair and checking and evaluating any damages from the view of the drone. Also, they can take screenshot of their interested view from the operating device of the smart glass individually. Moving on to the second topic, which is utilization of 3D scanning and development of 360-degree editor. In repair and seismic retrofitting design of existing old bridges, the designer requires final as-built drawings to base their design. In most of the cases, there are often no drawing left, and even if available, design drawings may have some errors due to the changes made during the construction. For that reason, the inspector on the site manually measure and create drawings and other design information, but it requires significant time, resources, and can cause measurement error. They often fail to capture all the details or may find errors in the original design also. Considering those problems, high definition surveying using laser scanner is introduced, which is a new method to capture a highly detailed 3D image during the inspection. In this method, instead of using conventional cameras to capture the virtual image, lasers, which are much more accurate, are employed. Some of the advantages of using 3D laser scanner are 3D laser scanning can be conducted with less manpower and in less time. So 3D laser scanner collects a set of data points, also known as point cloud data, and maps them on a grid coordinate of X, Y, and Z so that the measurements can be taken on the PC. Unlike normal JPEG photos, we can also check the 3D scan in 3D. Some of the uses of 3D scan data are as follows: mapping existing site conditions in renovation and rehabilitation projects, validating proper design execution, measure and evaluate progress. Using 3D scan, we can also create 3D building models. This video is about the complete workflow from data acquisition on the site to 3D model creation for one of our repair and seismic retrofitting project. So the transparent air bubble are the scanner setups on the site. And this is the 3D virtual view. So using 3D scan, as I have already mentioned, measurement can also be taken on the screen. This is our final report of 3D model preparation using laser scan data. So as you all have noticed on the previous video, the workflow to create 3D drawing and 3D modeling starts from 3D laser scanning on the site, followed by point cloud data processing and deleting unnecessary data, and finally creating 2D drawing and 3D models. This is a normal method to create drawings from the scan data. However, we are working on developing an automatic drawing generation tool or software so as to make the whole process of 3D modeling and 2D drawing creation much more easier. With being this technology easy and very convenient to use, it still has some inadequacies. For example, creating building information model is laborious and quite costly. 3D scan have a large file size, and delivery to the client requires a large storage capacity medium. Similarly, a dedicated application is required to open a 3D scan image, which may not be available with everyone. Similarly, we also have developed a much more user-friendly Kimoto 360-degree editor, which only requires us to take pictures with a normal 360-degree camera and combine the spherical photographs to create a 3D virtual model. That is why users can have a virtual walkthrough experience of the project site. With 360-degree visualization, we can see the site from the same perspective as if we were in an actual site. The model prepared using this editor can be used as a 360-degree spatial smart library, as various applications such as Word files, Excel, PPT, etc. can be attached into this model. And it has a relatively low file size than 3D scan. Similarly, complex structure and damage position can also be confirmed in 3D. And normally, 360 image cannot be viewed without utilization of VR application or cloud VR, which requires significant cost. But there is a free VR app version of Kimoto 360-degree editor like Adobe Acrobat. And this VR software can be provided to the client. Until now, the model prepared using this 360 editor has no measurement option of the structure. So our future development in this 360 editor will be the possibility to measure the structure inside the model itself. This slide is about the basic overview of Kimoto 360-degree editor. It primarily requires 360-degree images, location map or design drawing over which the camera setup are placed, and attachment files to create a 360-degree spatial smart library model, which has relatively low file size. On one click on the link icon, we can open and view the information attached. Let us watch an example model, utilization under the breeze girder. In this virtual model, we have attached important details such as damage photos, design reports, etc. And thus we submitted this model as a digital report to the client. So most of our clients have evaluated our model prepared using this 360 editor, easy to evaluate. Yeah. Similarly, the 360-degree editor can also be applied in dark areas, such as inside a hollow box girder with minimal lighting equipment. The inside of the hollow box girder is very small and narrow. Therefore, even if we take a 2D picture, we will not be able to know where we were taking that picture on the later stages of the project. However, we can use 360 editor to find out where the damage is located in 3D. Yeah. So moving on to the third topic, we have development of water drones. Water drones work on the same principle as the aerial drone works on. It is driven by 4 air propellers mounted on the deck of the boat. Because it is an air propeller, underwater aquatic plants and algae will not get stuck in the propeller during the operation. So if the water depth is 10 centimeter or more, the water drone can be used in most of the water bodies. However, it requires an operating space minimum of 350 mm height and width of 1,500 mm. Currently, we have 2 models of water drone. One is yellow water drone, and the second one is underwater sonar drone. The yellow water drone has a camera and LED setup. And this drone is basically used for routine inspection of narrow structures, such as under the box culvert. Whereas underwater sonar drone, on the other hand, can be used to investigate the scour depth of riverbed around a pier or abutment. Yeah. So inspection of high water level box culvert by conventional method or manual inspection is quite difficult and dangerous. There may be risks of submersion of the inspector, emission of poisonous gases, etc. Also makes it difficult for an inspector to conduct the inspection inside a narrow waterway box culvert. As you can see in this picture, it is quite difficult for the inspector to investigate. Therefore, water drone can be efficiently used in such places, like in this picture. The video on the right side is about the actual inspection on the waterway box using the water drone. So it can freely move inside the narrow box culvert. Similarly, while conducting periodic breeze inspection in Japan, it is necessary to conduct a scour survey around the piers and abutment. Currently, scouring surveys are conducted by manual measurement, such as using measuring staffs. Diving measurement is also employed, but the labor and the cost requirement are huge. We also have developed AUV autonomous underwater vehicle and ASV autonomous surface vehicle to conduct large-scale underwater survey, but it requires large-scale equipment, so it is quite difficult to use them easily during the breeze inspection. Using underwater sonar drone, the underwater mapping can be easily done for the investigation of scouring phenomena. The analysis report can also be shown by creating a 3D model using the data as we can see on the video at the right side. Moving on to the fourth topic, we have development of local live streaming with 4K web camera. In many cases, it is often necessary to report very significant damage from the site for which immediate solution is needed. Reporting can be done using a normal webcam, but the image quality of a regular webcam is very low, and minor damages such as cracks of around 0.1 mm cannot be clearly seen in the office or in the client side. Therefore, we have developed a local live streaming system using a 4K high definition camera to deliver clear images to the client front or participant from the office, export from the office. This camera is also compatible with all devices supported by Android, iOS, or Windows system. A live web interaction can also be conducted where clients participant from the client side, expert from the office, and inspector on the site can participate in real group discussions on serious damages, and the experts from the office and the participant from the client can also instruct the on-site inspector what to do next. The next topic we have is introduction to non-destructive test, under which we have concrete tester, which is used to determine compressive strength of the concrete. As we all know, rebound hammers have been widely used for non-destructive compressive strength testing of concrete for a very long time, but the standards for calculating compressive strength using rebound hammer varies from country to country. In Japan alone, there are many standards to calculate compressive strength. Similarly, the concrete tester is also a non-destructive concrete compressive strength testing estimating device. It can be used to measure mechanical impedance or spring coefficient of the concrete surface by the direct hammer blow, then estimating the compressive strength of the concrete. In addition to compressive strength of concrete, it is also possible to detect the degree of surface deterioration of concrete as an additional information. This device consists of a main body and a hammer unit. To measure compressive strength, we just require to tap the surface of the concrete with a hammer. All the measurement data are recorded on the SD card and the results can also be produced in Excel format via a dedicated program on a personal computer, which can greatly reduce the data organization time. The basic principle of concrete tester is measuring maximum force and hammer speed during the hammer blow. The yellow part on the hammer body is the accelerometer, which measure maximum force and hammer speed at which the concrete surface is struck by the hammer. Since the concrete is an elastic body, when it is hit with a hammer, the surface of the concrete dents and returns to its original state. The elastic properties in these three stages, as in the picture, can be confirmed in relationship between the acceleration and the time. On the active side, surface deterioration may be observed from the hammer blow, and that is why the strength of the concrete may be affected in the active stage due to the effect of energy loss. Whereas on reactive side, the effect of energy loss is reduced significantly. Hence, it is possible to calculate the strength index value that reflects only the elastic properties, which is not affected by the surface condition. The current slide is about the comparison of strength test using rebound hammer and concrete tester. As we all know, the surface where rebound hammer test compressive strength test using rebound hammer is conducted should be smooth and dry. So depending on the condition of concrete surface, there may be a large error in repulsive hardness. Whereas the test result using concrete tester is almost constant regardless of the condition of the concrete surface. Likewise, the rebound hammer had to measure a set of rebound value and calculate the compressive strength by test work. Even correction is also necessary for angle of placement of the plunger. In case of the concrete tester, the compressive strength of concrete is analyzed internally and displayed on the monitor automatically. So this saves times for both on-site work and desk work, obviously. There is also a limitation of maximum force that can be exerted on the surface of the concrete using rebound hammer. So it is difficult to be used in case of high strength concrete. But the result of a concrete tester has a better accuracy than the result in Smith hammer test. So this is the numerical comparison between rebound hammer and concrete tester. The rebound hammer had an error of plus minus 50% in uniaxial compressive strength test result due to the unevenness of the concrete surface, whereas the concrete tester has improved accuracy of plus minus 15% error. The compressive strength estimation range for rebound hammer is just from 10 Newton per mm square to 70 Newton per mm square. That is why it is difficult to be used to test compressive strength of high strength concrete. The estimation range for concrete tester is 10 to 150 Newton per mm square. So it can be used for high strength concrete testing also. Data correction for rebound hammer is required, whereas for data correction is not required for concrete tester. Similarly, the number of measurement points that can be measured or data organization time for concrete tester is higher than the rebound hammer test. This video is to show utilization of Smith hammer and concrete tester on the same site where core samples for compressive core test were taken previously. We are extremely sorry because our video may not be playing smoothly there. So we beg your pardon. So using concrete tester, after a direct hammer blow on the concrete surface, the compressive strength of the concrete is displayed directly on the screen of the concrete tester, which is this STR is the compressive strength, and 25.4 is the compressive strength in Newton per mm square. Yeah. The current slide is to compare the result of 3 test methods: core sampling test, Smith hammer, and concrete tester. The compressive strength test for 3 core samples are 25 Newton per mm square, 25.2 Newton per mm square, 23.4 Newton per mm square, respectively. Similarly, the compressive strength obtained for Smith hammer test is 32.1 Newton per mm square, whereas it was 27.732 Newton per mm square for concrete test hammer. The percentage error in compressive strength obtained from rebound hammer test is greater than 30%, whereas it was less than 15% in case of the concrete tester. So the next topic is ORIS exploration. Yeah, many disasters such as earthquakes and floods frequently occur in Japan. For strength verification of existing structure or for various reinforcement designs, such as in repair, maintenance, and rehabilitation, all design report or information may not be available in most of the cases. The shape can be confirmed by measurement or surveying in the aerial part, but not in the underground part. In addition, the damage to the underground structures after a disaster cannot be confirmed easily. For this reason, ORIS exploration technique can be used to investigate shape and damage in the underground structure. For example, it can be used to estimate the depth of the wall structures, foundation, depth of sheet piles. Similarly, it can also be used in PC steel wire breakage investigation, investigation of effect of alkali silica reaction, and such. Like the ORIS exploration, uses the principle of impact elastic waves to detect the shape and damage of the structures in the ground, buried in the ground by non-destructive technique. In this method, the time at which the shock wave hit by the hammer returns to the deep position or damaged position of the structure is measured, and the elastic wave velocity of the structure is multiplied by that time to confirm the shape and damaged position. This is the location of the crack, and the little wave is the bottom position of the concrete surface. Yeah. With this, our main presentation is completed, but Mr. SHOUBUZAKO would like to share some more about our future development plan. So may I request SHOUBUZAKO-san.
Thank you, Rupesh. At the last of our presentation, I would like to talk a little about the technology currently under development. And the development technology introduced today have already been put into practical use. We are still doing a lot of research and development. For example, regarding the bridge inspection by using drone, we are developing as follows. Currently, we are operating with Wi-Fi. But we are proceeding with development to shift to mobile phone radio waves, 4G or 5G. This merit is that you can operate the drone from the PC in the field. This makes it possible to check for damage in the field without the need for professional personnel to go to the site. We are also developing a drone equipped with AI to determine damage. This can notify on-site inspector and office or bridge managers in the event serious damage. In addition, by installing a spatial touch panel function on the smart glasses, for example, just like in HoloLens Extra, you can operate the drone by spatial operation. Since it is still under development today, I'm not able to share the details, but I would like to introduce it if there is another opportunity. That's all for today's presentation. Thank you, everyone. We hope you all liked our presentation. Thank you.
Thank you very much, Engineer Masayuki and Engineer Rupesh. for sharing the interesting technologies which can improve the efficiency, safety, and accuracy in a bridge inspection. I hope everyone also get this valuable knowledge in those technologies.